Welcome back. If you see Praskovia today, wish her happy birthday. Cool. Sweet. So today, super chill. We have gone through everything. And on tests, just to make sure, so TOD's not been here for tests and stuff. What's the bulk of your grade in my class? Tests. Now, everybody has a bad day. It happens. Bombing a test does not mean you don't understand the material. There could be a million reasons, right? If you know the material, why might somebody bomb a test? Like, let's say I came in to take it, and no offense, but I think I know the math at least as good as you do. If I know it and I'm comfortable with it, could I still bomb a test? What could possibly happen in my life that would lead to me bombing the test? There's like a million answers here. I'm not looking for anything specific. Okay, Vincent, let's say you studied and you felt comfortable with it, but you come in the next day and you bomb the test. What's one reason you might have bombed that test? So maybe you just forgot everything. But if you studied, I don't know that I think you're really going to forget everything. Anything happen in your guys' personal lives? Do you guys have lives outside of this room? Oh my gosh. At night, do you sleep? Is it possible that somewhere there's a family issue of some sort that you don't get a ton of sleep and you don't get any sleep and all of a sudden you're coming in tired and you're going to bomb the test, right? And that sucks. But it's not the end of the world. For every test that we take, what is the option? So we'll go over it. You do the reflections, right? And TOD will talk about this if you have to wind up retaking it. But after every test, remember, and I just want to stress this because every year at conferences or at whatever, people say, oh, I didn't know they could do this. But I'm making sure we all cover it over and over. If you bomb the test, you can do reflections. Tell me what you did wrong, fix your mistakes. You can take a different version for how much percent? I think it's 90 on the first, I think so. 90%. So if you get a 13% on the first one, that sucks. You will have an F in my class, I guarantee it. But it doesn't have to stay at 13. To retake your test, you got to do the reflections. Carson, is there anything else that you need if you want to retake a test with me? So we'll go to everybody. What is the only other thing that I need to make sure before you retake your test? What opportunity do I give you guys to master and practice a material? So I'm going to give you a note card to put stuff on it. If you don't do any of the homework and do any of the practice, are you going to do well on the test? No. Now, sometimes you might find the homework tedious and maybe not truly necessary, but it is necessary if you want to be able to retake it, because if you're not going to take the time to practice and improve, I'm not going to give you the other one. No missing work, which I always take late work, cool, and the reflection stuff. Now, with all that said, hopefully we just don't need it because everybody like slays this test or cooks with this test. I don't know the right vernacular. Something. Cool. All right, let's do some problems. We're just going to ease right in. Now, we don't have to knock out the converse of the theorems that we did the other day because we just knocked them all in at once. We have been talking in 6.5 about special parallelograms, of which there were 3 that we discussed. What's one of them? So Lily says rhombus. Somebody not Lily, what's a rhombus? And we're going to do it this way. And yep, Andrew, I like what you're doing, because if you don't have it ready to go right now, I would probably get it ready. I'm going to ask 3 questions. I want you to talk with your neighbors for like 30 seconds as quickly as possible, and then we are going to randomly call a few people. Rhombus is one of them. I'm going to ask about that. What's another one I'm going to ask about? Squares, and one more. Rectangles. Guarantee I ask you some questions about those, which means in my notes or in your notes, I would probably have access to the theorems regarding rhombi, the theorems regarding rectangles, and the theorems regarding squares. I'm going to call randomly in about 30 seconds and ask you for a bunch of those properties. Be prepared. Talk it out, help each other find it. 30 seconds from now, I'm going to start calling people to give me some key features of some of these things. Hustle. Okay, we're going to call 10 seconds. I'm going to start calling some randoms. All right. Check it out. Number 8. I don't have your numbers in my heads. I like how everybody always looks at the phones to see where your phone is. Do you guys know it without looking at the phones? Raylene, what number are you? Don't look over there. Are you confident with that? Okay, cool. All right, number 8. Give me something special about, I don't know, rhombus. Should we just wait awkwardly or probably just call somebody else, huh? All right, just kidding. Number 3. Something about a rhombus. What's true about a rhombus? That's you, right? Give me something that's true about a rhombus. Like, what is a rhombus, I guess, first? Can you say that like 10 times louder? We'll go one more try. So, and we can, for this, good call. So quadrilateral just means 4 sides. And you can just call it a four-gon because it's a polygon with 4 sides. So quadrilateral with what? What do we know about the opposite sides of a rhombus? Or all the sides of a rhombus? I'm stuck. All 4 sides are? So opposite sides are parallel for sure. I agree with that. Like, you're okay. You like, I think that, whatever. You're good. I agree with that. What else is true? All 4 sides, opposite sides are parallel. There's one more fact about those opposite sides, though, or all the sides. Actually, we're making pretty intense eye contact here. All 4 sides congruent. Is there another shape that has all 4 sides congruent, Carson? A square. How do you differentiate between something that's a rhombus and a square? Like, a square is a rhombus, just for the record, because all 4 sides are the same. But what's the distinguishing thing between them, Camille? How could I have a rhombus but not a square? I'm going to change that question because it's hard on the spot, and I get that. If I give you a square, there's 4 right angles, right? Does every rhombus have that? So if I said what distinguishes a rhombus between a square, all we need is those angles. But if you give me a rhombus that's not a square, or if it is, what do I know about the opposite angles? They are congruent, Ashley quietly. It's not lip sync, I guess, probably. I don't know the word. Okay, what's a rectangle, and what's true about their diagonals, Carson? Mm-hmm. They are congruent. Do they do anything else to each other? They bisect, and that's not a rectangle idea. That's a bigger idea that covers all these. What shape has diagonals that bisect each other all the time? It happens with rectangles. Rhombuses. Is that true? I don't think so. Interesting. So that is a rectangle property. Now, as we go through, like right now, I'm hoping that you remember a bunch of these. Are there properties of these shapes that you don't recall? Like realistically, we have like 23 theorems. Do you think there's pieces that you just don't remember? I don't make you memorize everything. What is my advice for you, knowing that we're going into a team test? If you don't want to remember all the theorems, what's your option? Say it again. So, won't work for a test, but I like that idea. That's a reasonable approach. Split the work up. Anybody have a different answer, possibly, of how you're possibly, like, how on earth are you going to be able to use 23 different theorems on a test if you don't remember all 23 of them? One more time? I don't even know who said it. Oh, my note card. What should be on your note card, do you think? I would say the theorems, for sure, that you won't remember. Now, we will get into that, and if I have to help with the note card a little bit, we will, but we're just going to jump in because I've done nothing but talk, and let's go. All right, so we're just going to start working some problems. Now, today's lesson is going to be crazy short, and you will have time for it, but we're going to work them like this today. So here we are, and I want to think about some of these. I'm going to leave it up to you guys. If you want to physically write it all out and all that good stuff, I'm okay with it. I do think there's value in drawing it. But what I want you guys to do for the next couple minutes, just to see, you need your notes out. On 5, 6, and 7, and 8, I want you to answer these with your neighbors real quick. Let's get a quick check. I'm asking you to classify each of these foregons as a parallelogram, a rhombus, a square, or a rectangle, with a few things that I want to pay careful attention to. If it is a square, is there any other pieces here that is guaranteed to be? If it's a square, is it a rectangle? And if it's a square and a rectangle, is it a rhombus? It has to be. And we'll look at that. Like, we'll put one more little thing in our notes here shortly. But there's possibilities of mixing these. Cool. I'm going to give us like 3-ish minutes. I'm going to keep this on the board. I want you and your teammate or you and your teammates, if you have to turn around to discuss a little more, talk through these. We're going to go like specific answers. So if instead of just saying, oh, it's a square, know that I will be asking why. Be prepared. Jot them down if you need to. I would encourage you to jot them down. I'm not going to require it. You should. Hint, hint. Cool. Here we go. These 4. I meant to pause it, but it didn't. Talk it out. This. I just want to be like completely honest. My approach and the way that I think about it, is it always going to be the exact same way that you do? Probably not, right? Now, we're all going to notice hopefully the same things, but the order in which we notice them and all that, it can change. Now, I guarantee 100% that I'll be asking you to classify some quadrilaterals for me. So there will be problems like these. I missed half of, nope, we're cool. Okay, so let's dig in and let's just kind of brainstorm here. Our first example, let's look at number 5 together. Anything stand out to you immediately on number 5 itself? And there's probably a bunch of stuff, but let me be more specific. Raylene, anything, what's the first thing that you notice on number 5? Can you say that like twice as loud? They bisect one another? Okay, so Raylene notices that these marks aren't there, but they're true. The fact that I have diagonals bisecting one another, what does that mean it is? Diagonals bisect each other implies parallelogram. Is that true? Do we have a theorem that says if it's a parallelogram, then the diagonals bisect each other? Okay, so we have parallelogram. Well, that's fine and dandy. I know it's a parallelogram. Good. What else do you notice, Vincent? And there's no specific answer, just whatever you notice about it. The one this same one. So it's a good first step. Do we have other theorems related to diagonals in any of our shapes? Like I know the diagonals bisect one another. If it's a rhombus, the diagonals bisect one another and make a special angle here. It'd be 90 degrees if it were a rhombus. I have no reason to think it's 90. It could be, and they're just bad at drawing. What about, do we have a theorem that says this diagonal is the same length as this one? If the diagonals are equal, which is what we see here, because both diagonals have a length of what? So I'm going to say congruent rather than equal. What does it imply to me if the two diagonals, Carson, are congruent? Okay, so right now we're at rectangle land. Do you guys agree? Now, rectangles have 4 right angles. And love that Carson pointed this out when I was talking with him. He said, as soon as I know it's a rectangle, I get these things. There's no other way that we know those are 90 until we decide it's a rectangle. So now the question becomes, is it a square? And can we say it's a square or not? So any other ideas? And I'm just opening it up. Anybody is welcome to speak here. If it's a square, what would we need? Four congruent sides. Now, right now, I'm going to make the claim, I know that this and this are the same. Why? It's a parallelogram. Drew, what do you know about the vertical here and this one over here, since it's a parallelogram? So those are the same as well. Now, the one thing that I notice is that this has 2 and this has 3. If there's a way to logically say that these both have 3, then we're good. We'll say it's a square. Anybody have a way to get there? I don't think I do. There's nothing that I know about a right angle in here to tell me it's a rhombus. Bummer. I don't think we have anything else that we can use. What do we conclude this is then? It's a parallelogram, but more specifically, it's a rectangle. We don't have enough to make any other determinations. Okay, for this, if you don't know the theorems, you at least need access to the theorems. My best advice for you is when we're working these, what should you have in front of you? Probably your notes is what I would say, your theorems. Or if you want to maybe put them all in one concise place, like, I don't know, a note card, where you can get all these things in a nice, easy to access location, I'd suggest it. We're going to knock out at least one more of these right now. We're going to bounce around to a few of them, and we'll just add. What's the other one we want to look at? 6, 7, 8. You can do it. I'll do it with you. Andrew, 6, 7, or 8. Which one are we doing? Love it. So on number 8, so here we go, and I'll just scroll down so it's the only thing that I see. And here we go. Number 8. First thing that stands out to you, Ashley, when we look at number 8, and we're coming in cold, we haven't put a whole lot of thought. Anything that you know for sure about this? Why do you think that? So it looks like a rectangle, but be very careful. If we want to show it's a rectangle, we can't say that the opposite sides are congruent, therefore it's a rectangle, because you're trying to show it's a rectangle. Like there's that wonky thing that happens. I noticed this, and I'm sure Drew notices this as well. I can tell that like he's thinking, yep, there's the marks there. As soon as I do those 2 marks, my first thought is I can't tell if they bisected. Do you agree with that? Like I'm not 100% certain that they have. Is that true? So rather than me just talking at you guys with glossy eyes, we are going to split it up. Are we doing rock, paper, scissors, or are we doing the number thing? Because you guys are going to talk this one out. And I'm going to call on like all 8 of you. Okay, rock, paper, scissors. Do you guys want to do a real class, like a big class rock, paper, scissors real quick to see who's the best? Okay, cool. Do you guys remember doing the big rock, paper, scissors in the gym? Ever? For pep rallies? Cool. Who's the best in here, do you think? That's right, it's me. Cool. So I won't play. How does this work? How does our rock, paper, scissors contest work? Deal. I want, let's see, Miss Allie to hear us here in a minute. All the way down there. Cool. Rock, paper, scissors. Best 2 out of 3. Go with your neighbors first. When you win, we'll turn around, and we don't need, like we have such a small class, easy. You 2 will play, and you 2 will play. The winners will play. The winners will play. Once you lose, who do you start cheering for obnoxiously? Whoever beat you. Cool. It's going to take like 30 seconds with 8 of us. Let's see who's the best. 2 out of 3. And just to be clear, it goes rock, paper, scissors, shoot. It's not rock, paper, shoot. Cool. Go. And talk. Where do we go from here? What on earth does this tell me? So Drew is claiming this, I think. Why? And not just Drew. That's open to everybody. If Drew wants to say this, either try to say, yeah, it's true because, or say, oh, it's not true because, but I want to think about it because that's a good thought. Like that's a natural thought. The picture certainly alludes to that. Is that true? Well, I don't know the answer. Don't look at me. So love to hear that. Is that a good logic? It's not bad logic, just so you know. Like that's not, it's not good or bad. It's just, is it correct logic? If it's a parallelogram, then I guarantee they do what? Then they bisect, right? So that would help. If it's a rectangle or if it's a rhombus, they would bisect and they'd all be equal, or is that just a parallelogram thing? If it were a parallelogram, they'd be bisected. If they were equal, it'd be a rectangle. Right? Okay, so now if we said that these 2 were the same and these were the same and they're right angles, we'd get a rhombus. But we need something else in here. I don't know that 100% that we can write this yet. I don't know that we can't because I'm just playing ignorant here. But you guys are going to help. Is that allowed? Or is there something else that we want to look at and then maybe come back to this? Brainstorm with your neighbors. We're going to try it here because I pulled you off task for a few minutes. See if what Drew is proposing is correct, or if there's something else that you notice that we might be able to say, but I want you guys to give it a go. Try it. I don't care if you're wrong. I care if you're being apathetic. Not pathetic. That's a different word. Apathy is like not caring. Cool. Be okay with being wrong. I just want ideas. Not good, not bad, just ideas. Try it out. Talk it out. See if we can come to anything with this. kind of curious if I stepped out, like if I weren't here, would they talk more? I don't know. I don't think so either. This is a much harder problem than the first one.
I think they're just maybe stuck on the definition.
Yep. And so the way that we'll do this is, does a lull mean that we came to an answer or that we're stuck? So they started talking more, at least Lily did. As we're going through this, do you know? Like this one's trickier.
Yeah, problem 5, going to use it,
Okay. Yeah, you're good. Tomorrow, so what we'll do is the team test tomorrow. I'll have them do it, and then they'll mark problems that they're not sure about, so that we can really zone in. And I'm deciding if I'm going to be super nice with a theorem list or not. Any ideas? I heard Lily talking out of everybody. Everybody else just kind of waiting. It's fair. Ooh, I love what you're doing, Carson. I hear Carson reading some theorems. So, well, let's just work it out. Remind me real quick, and this is good review, and maybe this is something that's like maybe note cardy. And we can add this in there. A square is a what? These are all parallelograms if we're talking about these three. But what makes a square a square? So let's break that down a little bit more because that's the most concise we can. What does it mean if it's a rhombus? So we get 4 congruent sides. And what does it mean if it's a rectangle? 4 somethings. 90-degree angles. Okay, so this is what we have for a square, right? So it's a 4 congruent sides and 4 90-degree angles. How about rhombus? What makes a rhombus a rhombus? So diagonals are perpendicular bisectors. What else? So 2 pairs of parallel sides, but that I'm just going to clump that in because we're talking about parallelograms. There's something else that's special about a rhombus. Certainly the diagonals are perpendicular, but there's one more really important one. So they bisect angles. I'm okay with that. And then Drew, I think you said something else. What do you know about the 4 sides of a rhombus? Good. 4 congruent sides. Now, this is what allows me to say, look, anything that's a rhombus doesn't necessarily have to be a square, but any square has to be a rhombus. And I can look at this. Okay, other piece, we're looking for a rectangle. What makes a rectangle such? So 4 90-degree interior angles. And these, like, I'm mixing and matching here between theorems and statements, but they're just all things that we know are true about it. Camille, what else do I know about rectangles? Something about the diagonals. Diagonals are congruent. Now, in this, maybe there's some other ideas floating out there that we're going to have to kind of bring in a little bit here. Do you guys recall ever working with Venn diagrams? Just a little graphic help here. If we have a collection, a set, there is, like, you could collect every possible rhombus and you could put it in here. So every single rhombus of all lengths will fit in this collection. Everybody okay with that? Okay, over here, we have all the rectangles. Every possible rectangle that exists will fit in this circle. What do we call the overlap? If it's a rectangle and a rhombus. So there's where our squares live. Now, this is a nice graphic to just kind of visualize it. You guys have dealt with Venn diagrams before. Have you dealt with a bigger Venn diagram than this? They get wonky, like they get challenging eventually. But let's just dig through here. I'm looking for any way to show any of these. Can I say that the 4 outsides are congruent? Do I have a reason to say that right now? Okay, so maybe not. I'm fine with that. Do I know any sides are congruent currently? Teoti's, I don't know if she answered really necessarily, but I saw a little bit of facial expression change, which makes me think there might have been a comment hiding there. Thoughts? I'm really trying hard to not just give us the answer. I might just put this one on the homework for tonight. That we actually have to answer it. I can't decide. Man, today feels weird to me. Does it feel weird to you? Like, I don't know if it's more quiet. I don't know what the deal is. Huh. Well, I'm looking for any other suggestion, or else this one's just going to go in the homework, and then we'll have to talk about it tomorrow as well. But then you'll at least think about it. Not that you're not thinking now, just for the record. I know you are thinking. What is this? What else do we know about it? Ooh, I heard somebody say it says something.
Well, it's a square
Why?
because the two vertical angles. Yeah.
Okay. So vertical angles, deal. That's a good start. Something that we know is true.
That would make the top triangle and the bottom triangle congruent as that.
But I don't have these sides marked.
Well, they're the same triangle, just upside down.
Well, maybe the picture's just bad.
Well, if you inverted it, it would be the same.
Okay, so we're trusting the picture here. I'm okay with a little bit of that. I think we can also say this must be true, if you're okay with that. Okay, so we're just going through, like, guaranteeing what's true. Now, for this, there might be some other stuff that we can work with. I am going to take the long way through this. I want you guys to think about this. Oh, Drew, you got another one?
Yeah, for 90-degree angle
Why?
because the top two are congruent, so it's 90 on top.
Does that have to be the case? So that's what Lily was suggesting, but my concern, unless you can convince me that these marks are here, I don't think we get side angle side. So I guess if we could get to these marks here, we'd be fine. And I'm going to reread the directions just really quickly, just to make sure they don't say it's parallelogram.
Wait, what's the?
So scratch this. I make this problem so much harder than I was intending, because I hid the directions here when I put this one up here. Yeah. We'll just check real quick, and I'm going to show you. You guys ever seen me not read the problem completely or not pay enough attention to when I'm reading? You guys ever not read the problem correctly or not pay enough attention to when you're reading? I've watched you all do it. I've watched me do it. I said I wasn't going to do it anymore, but here I am doing it. For exercises 5 through 8. Finish that for me, somebody. Is the what? Oh my goodness. If we read the directions carefully. Is this true already? Is this true already? Is this true already? I'm going to use 3, so they're different. Does this add stuff to us? Oh my, so much. As soon as I've corrected the mistake that 6th, 5th hour won't have, thank you. How do we get here now? I think I can run with Lily's idea. What do we know the diagonals of a parallelogram do to each other? So if this has 2 dashes, what does this have? And this. And so now we get those triangles are the same, and we're there. And Lily, if you had said because it's a parallelogram, I probably would have shut you down, but you would have been correct. Okay. Okay, so now check it out. 2 dash plus 2 dash, is that same as 2 dash plus 2 dash? So the diagonals are congruent. Well, what is it? Guaranteed. The diagonals are congruent. So we already know it's a rectangle. So now it's just a matter of determining if it's a square, right? Okay, so looking at these, this triangle is congruent to this triangle. I don't know that these ones are congruent to each other yet, or these two are congruent to each other, I'm sorry, but I don't know that that's congruent to that. Would you agree? So if we want to say it's a square, we would need to get some Ramus properties out of this then. Right now, do I have a way to say that this side's the same as this side? These two sides with 1 dash, right now they don't look the same, right? Do I have a way to say they are? And just so you're aware, like as I'm thinking through this, in my head, I'm thinking top triangle and bottom triangle automatically is where my head goes, because I know that this triangle has 1, 2, and this has 1, 2, and they have that same diagonal. So these big triangles are congruent. So I'm trying to think my way through, are there any other pieces? I don't know that we're going to get to the point that it's a square. So a couple things, terribly sorry that I did not read my problem carefully, but it's a good exemplar to say you should really make sure you do what? Read the directions. Terrible, terrible mistake on my part. So what do we decide? What do you think it is? At least for now. Rectangle. I'm going to challenge, if you want to look at it a little bit more, see if we can get further with it. These problems got 1,000 times easier when I read it correctly, first and foremost. looking at these, we have a variety of these problems. Just like this, identify it. If we look at one more, and let's see if we really want to truly look at one more. Can I get just a gut feeling? Thumbs up. I feel good about these. I feel bad. Where you're at. Okay, so nobody's like here with tears running down their face or anything, which is a good sign. So we're going to be super chill today, and I'm not going to make the mistake. And I'm kind of mortified right now. Can you tell how embarrassed I am currently? I'm going to cry myself to sleep tonight over this mistake. I guarantee it. Follow up. How sincere am I currently? Am I really going to cry myself to sleep tonight? I know the answer. All right. So what I want you guys to do is I want you to add to last night's assignment, and we'll make it not terrible. Lily, Camille, and Raylene, did you guys finish the assignment last night? Almost. How far did you get, Raylene, just out of curiosity? Halfway? Okay. I want you guys, I know we didn't do a ton of these, but based on the thumbs up and thumbs down, you're going to add to last night's assignment, page, lost my number, 296. And I want you guys to knock out problems. How many do we want? I'm starting at 50 unless anybody has a oppositional opinion. Everybody's cool with 50 problems? Hey, that was a word. Cool. 17 through 23 odd. I've talked myself out of 50. Cool. Now, just so you're not surprised, and to make sure that we haven't, I'll add this to the Google Classroom. That is what we're doing tonight. Tomorrow we're going to come in, we're going to check the assignment, and then what other super fun thing do we get to do tomorrow in class? Practice test. Okay. I'm not going to give you guys no cards tonight, and there's a reason, and we'll review that all tomorrow. But this evening, and for the next 5 minutes, I want you guys to start here. Cool. Or if you're not starting here, start at 18. Wait a second. Yeah, that's a different page. We're good. Cool. I thought there was overlap, but this is the next section. Cool. All right. 6 minutes. I want you to get started on stuff. Sweet. Absolutely, I can help you with 18.